Well, hello and welcome to skill lesson 16, parallel and perpendicular lines. So I thought it would be appropriate here, just coming off of our skill lesson of parallel lines in a transversal, to also look at parallel lines in a different context on the coordinate plane, and of course, view them alongside our counterpart, the perpendicular lines. So as always, feel free to read through and look through the examples. But the purpose of this video is to assist you with the practice. So let's go ahead and scroll all the way down till we get to the practice portion of our skill lesson. So it tells us, for number one, find the slope for each equation, then determine the slope of a line that is parallel and the slope of a line that is perpendicular. So when two lines are parallel on the coordinate plane, they will have the same slope or equal slopes. And when two lines are perpendicular on the coordinate plane, they are going to have what's known as negative reciprocal or opposite reciprocal. So if the slope of line A and they're parallel, it's going to be equal for the slope of line B. But if they're perpendicular, whatever the slope of line A is, the slope of line B will be the opposite reciprocal of that slope. So it'd actually be 1 or negative 1 over m over A, or the slope of A. And we'll explore that a little bit further here in these examples. So on item 1, first thing I want to mention is that this equation is written in slope-intercept form. Slope-intercept form is y equals mx plus b, where the coefficient of x, we call the letter m, represents the slope, and b represents our y-intercept, hence the term slope-intercept. Now, we love to see equations in this form because we can see in the equation what the slope is of our line. It is the coefficient of x. So on number 1, y equals negative 6 over 11x plus 7, this coefficient, and a coefficient is simply a number or term in front of a variable, multiplying by that variable. So this term or coefficient here in front of x is our slope. So first thing we're going to write, because m is typically representing slope, m equals negative 6 over 11. If you notice, I did not write x at the end of that. Slope is the number or term in front of x, not x itself. Then it says determine the slope of a line that is parallel and the slope of a line that is perpendicular. So a parallel slope, and that's not the number 11, that is the symbol for parallel. A parallel slope or a parallel line to this linear equation here is going to have the same slope. So if the slope of our original line is negative 6 over 11, then the parallel slope will also be negative 6 over 11. Now, the perpendicular slope, think about it, two lines that are perpendicular have to intersect to form a right angle. So they can't have the same slope. That would actually cause them to be parallel and they wouldn't intersect, but they need to intersect in a precise way to form 90-degree angles. So the perpendicular slope, and that's the symbol for perpendicular, is known as the opposite or negative reciprocal. So what we're going to do is we're going to change the sign of our original slope, negative 6 over 11, so it's going to be positive. And then the term reciprocal means for us to flip or reciprocate the fraction. So instead of 6 over 11, it will be 11 over 6. Just a quick math reasoning here of why the perpendicular slope is 11 over 6. When two lines are perpendicular, their slopes should be able to multiply and produce the number negative 1, hence the term opposite reciprocal. So I should be able, just to check, take our original slope, negative 6 over 11, multiply it by our perpendicular slope, and I should produce the number negative 1. So negative 6 times 11, just multiply across, is negative 66. 11 times 6 is positive 66. and a negative 66 divided by 66 is a negative 1. So that's how we know we got the correct perpendicular slope from our original equation. Now moving on to number 2, this is written in what's called standard form. Now standard form has a lot of uses in mathematics, but for us to be able to really determine the slope of the line, we probably need to go ahead and write it in slope-intercept form. So if you notice, in standard form, x and y are on the same side of the equation. In slope-intercept, x and y are on different sides of the equation. So that's how I approach it first. And seeing how slope-intercept form, y is on the left side and x is on the right, that's what I typically do first. I'm going to move this x term, 3x, across the equal sign by subtraction, because it is a positive 3x trying to add to 2y. So to move it across the equal sign, I need to subtract it. So 3x take away 3x is 0, so we call that canceling. Bring down the 2y. 12 can't subtract 3x because they're unlike terms. So all we can do is show that negative 3x and 12 want to combine. And going back to slope-intercept, I see that the x term is written first, followed by the y-intercept. So that's what I'm going to do. I'm going to bring down the negative 3x and then show that I want to add it to the 12. And if you're wondering why did I write plus 12, it's because this is considered a positive 12 because we don't see a sign next to it. Now the last step to write in slope-intercept, if you notice, slope-intercept is set equal to y. Well, our equation right now is set equal to 2y. So we have to perform an operation to get rid of that 2. Well, 2 is trying to multiply by that y, so to get rid of that multiplication, I divide it by 2. But the golden rule of mathematics says whatever I do to one side, I have to do to the other. So technically, I need to divide everything over here by 2. Now, a more appropriate way to do this, so it can simplify a little bit easier on us, is I'm going to show that each term over here is dividing by 2. So 2 divided by 2 on the left becomes the number 1. So we don't have to write a 1 in front of a variable. It's an understood 1. 2 can't divide into negative 3 here, and they can't simplify, so we can just leave it as negative 3 over 2 x. Notice I'm trying to write it in this slope-intercept form. And 12 can, in fact, divide by 2, and we get positive 6. So now you see that this standard form was converted to slope-intercept form. So let's establish the slope of our line. Again, it's the coefficient of x, so our slope is negative 3 over 2. And yes, please keep slope in improper fraction form as long as it's simplified. I don't like mixed numbers or decimals for slope. Really complicates things when we try to graph it. The parallel slope will be equal to our original slope because parallel lines on the coordinate plane have the same slope. And our perpendicular slope will be the opposite reciprocal. So our original slope was negative, so our perpendicular slope will be positive. Our original slope was 3 over 2, so our perpendicular slope will be 2 over 3. Now we're just going to show the mathematics behind it just to make sure. I should be able to take my original slope and my perpendicular slope and multiply them and get negative 1. So I'm going to take negative 3/2, our original slope, multiply a positive 2/3, our perpendicular slope. Negative 3 times 2 is negative 6. 2 times 3 is positive 6, and negative 6 divided by 6 is negative 1. So we did find the appropriate perpendicular slope. Now let's move on to our next section. It says use the diagram shown for items 3 through 6. So we have a line here, line T, and 2 other points not on the line, point E at negative 6, 1, and point D at 6, negative 5. So let's see what they want us to do with it. Number 3 says, what is the equation of the line through point D that is parallel to line T? So we needed an equation, and they don't specify what form to write the equation in, so we'll just assume slope-intercept. That'll be the easiest to do here. So we're going to write the equation of the line. Well, I'll go and write slope-intercept through point D that is parallel to line T. So the first thing we need from line T is the slope of line T, because we know that parallel lines on the coordinate plane aren't going to have the same slope. So there's multiple ways to find slope, but given a diagram, the easiest way is to simply count the units between 2 points using the terms rise over run. So they have given us 2 points here. For sure, we know those 2 points are on the grid. So I'm going to start by this lower point, and I'm going to go up till I get to the same level on the y-axis as the other point. So I'm going to go up 1, 2, 3, 4 units. So I'm going to write a 4 here. Well, that's what we call our rise. You might have heard the term rise over run. So we're going to rise 4, and then let's see how much we have to run. So from this point, we're going to count 1, 2, 3, 4, 5, 6. So a run of 4 over 6. Well, anytime you encounter a fraction, you have to ask yourself, no matter what context it's in, can that fraction be simplified? And yes, 4 and 6 have a common factor of 2, so I can divide the top by 2 and the bottom by 2, and I get a simplified fraction of 2/3. The reason this slope reduces to 2/3 is that there is actually another point right here that falls on the line and on the grid. We could have simply counted up 2 and write 3. So what I'm showing you here is that a slope between any 2 points on a line should be equivalent. Notice we went a little bit further up and a little further over and got 4/6, but it's still equivalent to the slope between 2 other points, 2/3. So we now have the slope of line T, which is 2/3, and we know that the equation of a parallel line has to have that same slope. So I'm going to use 2 different methods to figure out the equation of the line through point D that is parallel to line T. And you can decide from here on out which method you prefer. So when we have a point and we have our slope, we can utilize a formula called point slope. Point slope is y minus y1 equal to m times x minus x1. Now it looks complicated, but it is literally designed to use a point and a slope and then produce slope-intercept form, which is what we're looking for. So m, of course, is our slope. So we're going to substitute m with 2/3 in just a moment. And x1, y1 is the point on that line. So they told us that we need a line through point D, which is 6, -5. So 6 is our x1, -5 is our y1. So now I'm going to do substitution property. So bring down my y minus y1, which is -5. Notice I left the negative from the equation, but also put in another negative because the y coordinate was negative, equal to 2/3 times x minus, and plug in x1, which is +6. Now our goal is to write in slope-intercept form, which is y equals mx plus b. So we need to simplify both sides and set it equal to y. So when you subtract the negatives, simplifying that just looks as just changing it to addition. Now simplifying this right-hand side, we obviously don't have any parentheses in slope-intercept form, so we need to distribute this 2/3. 2/3 times x is 2/3 x. And 2/3 times -6. Let's look at that math real quick over here. So 2/3 times -6. So anytime we're multiplying a fraction times a whole number, I typically put the whole number over 1 because any whole number could be written over 1 because 6 divided by 1 is still 6. And then we just multiply across. 2 times -6 is -12, and 3 times 1 is 3. Again, we ask ourselves, a fraction, can it be simplified? Absolutely. Not only do 12 and 3 have a common factor, but 3 can divide in evenly to 12. So a -12 divided by 3 is -4. So we'll bring down -4. So in other words, 2/3 of -6 is -4. Last but not least, to write in slope-intercept, we need to move this +5 away from the y. Well, that 5 is trying to add to y, so to move it across the equal sign, we have to subtract. And it is a like term to -4 because it doesn't have a variable like our x term here. So that's why I put it under the -4. +5 minus 5 cancels or becomes the number 0, and we're left with y equals 2/3 x Negative 4 minus 5 is negative 9. So there is the equation of a line that is parallel to line T that passes through the point D. Now I'm going to show you the other way to approach it, and some of you might appreciate that way just a little bit more. So if two lines are parallel, and you could also graph this. I can encourage you to graph this equation of line. I'm going to show it to you a little bit more formula-based here. But when two lines are parallel, more than likely they are going to cross this y-axis. They're going to have the same slope for sure, but they are going to cross the y-axis in a different location. Think about it. So if line T is right here and there's a line parallel to it, it's going to cross the y-axis in a different spot than line T does. So what that means is it's going to have a different y-intercept. So what we're going to do is we're going to use slope-intercept form to find that new y-intercept. So for the equation of the line through point D that is parallel to line T, we know that it's going to have the same slope as line T, and we've already established it's 2/3, but it's going to have a different y-intercept. Notice I put a B there in its place. Well, if the point D falls on this line that we're trying to write the equation of, then this coordinate should satisfy this y and x. Well, if you notice right now, our goal is to solve for b, but we have 3 variables missing. Well, if point D falls on that line, then this coordinate should satisfy the x and y of this equation. So if I substitute x and y of this equation with 6 and negative 5, the only variable I will have left is b. So I will be finding the y-intercept of the line through point D that is parallel to line T. So that's what I'm going to do. So I'm going to replace y with negative 5 from point D and x with positive 6 from point D. So what I need to do first is simplify this side because I can multiply 2/3 times 6. So I'll bring down the negative 5. 2/3 times 6, I'll just do the math real quick right here. 6 over 1. 2 times 6 is 12. 3 times 1 is 3. And 12 divided by 3 is 4. So this simplifies to positive 4 plus b. Now, our only task here is to get b by itself, and b is trying to add to this positive 4, so to move it across the equal sign, I have to subtract it. 4 take away 4 is 0, so I'll be left with b equals negative 5 minus 4, negative 9. So to write our final equation, what we have to do now that we solve for b is go back and substitute negative 9 for b in this equation. Y will equal 2/3 x minus 9. And notice it's the exact same equation we did before using point slope. So for number 3, the answer is y equals 2/3 x minus 9. So if you prefer this method, feel free to use it from here on out. Oftentimes I see students forgetting to actually go back and plug that value in for b. So that's why I kind of tend to use point slope form. But whatever method you prefer is great for your understanding. So let's take a look at number 4. Number 4 says, what is the equation of line through point D that is perpendicular to line T? So we're going to use the same point. We're going to use the same line T, but now we need to find a line, the equation of line through this point right here that's going to be perpendicular to line T. So recall that if it's perpendicular to line T, it has to intersect, perpendicular lines have to intersect to form right angles. So we're not looking at a line that's parallel to line T like we just did. We're looking at a line that can intersect T, go through point D, but also make a right angle. That's pretty good. Obviously, I wouldn't just chance that. So we're going to actually look at it mathematically. So we've already established that the slope of line T is 2/3. So we need to next establish our perpendicular slope. Well, it is the opposite reciprocal of our original slope. So our slope here was positive, so our perpendicular slope will be negative. And it was 2/3, so now it will be 3/2. And that, truthfully, is the only change between what we're going to do on item 4 and what we did on item 3. So now that we have our slope and we have a point that the line goes through, we're going to use point slope to write the equation. So y minus y1 will equal to m times x minus x1. So recall that x1 and y1 are the point on that line. So 6 will be x1, negative 5 will be y1. So I'll do some replacing there. Y minus, again, I'm going to write that negative 5. And the only change here is we're not going to use the original slope, 2/3. We're going to use our perpendicular slope, negative 3/2. So for m, we're going to substitute it with negative 3/2. Parentheses, x minus, and x1 was positive 6. Now I'm going to simplify both sides. Y minus a negative 5 just changes to addition. And then we're going to distribute negative 3/2 times x and negative 6. So a negative 3/2 times x is simply a negative 3/2 x. And a negative 3/2 times negative 6, we'll show that work over here. Again, I'm going to put negative 6 over 1 and then multiply across. Negative 3 times negative 6 is positive 18, because a negative times a negative is a positive. And 2 times 1 is 2. Now again, 18 and 2 have a common factor, but furthermore, 18 can divide by 2 evenly to get positive 9. So I'm going to go and write a positive 9 here. Our last and final step, because slope-intercept is set equal to y, not y plus 5, is we need to move this positive 5 over by subtracting 5 from both sides. 5 minus 5 is 0. Y will equal negative 3/2 x. Positive 9 take away 5 is positive 4. And if you notice on the graph, positive 4 was actually right here. So obviously my line was a little bit off. So, it can be wise to use your graph as long as you know how to handle it appropriately. Obviously, me drawing this line pretty quickly didn't quite get the work done for us. Now let's look at item 5 using this same diagram, but I imagine the problems are going to be a little bit different, more than likely involving point E. So number 5 says, what is the equation of a line through point E that is parallel to line T? What is the equation of a line through point E that is parallel to line T? So we're going to approach it the same way we did item 3, but now using point E. Fortunately for us, we already know the slope of line T. It's 2/3. So if we're looking for the equation of a line through point E that is parallel to line T, we know that parallel lines on the coordinate plane are going to have the same slope. So the parallel slope we're going to use will also be 2/3. Well, we have a point that our line passes through, point E. So I'm going to use point slope because we have our slope and we have our point. So again, point slope is y minus y1 equal to m times x minus x1. If you write it enough, you'll definitely memorize it. I know it looks complicated, but that's how all your math teachers learn these formulas, is we wrote it down enough. So recall that in this, for point E, negative 6 will be x1 and 1 will be y1. So we'll do some substitution, y minus y1, which is positive 1. Bring down our slope, which is a positive 2/3, and x minus x1, which is negative 6. Recall, like on the last one, when there was already subtraction involved in the formula and I plugged in a negative value, that I have to write both negative signs, because I will now go ahead and change that to addition. When we subtract a negative, it is addition. So I'm going to go and make that quick change before I do any distributive property. So change it to positive 6. So we're writing in slope-intercept form. So let's simplify our right-hand side by using distributive property. So y minus 1 will equal 2/3 times x, which is 2/3 x. And 2/3 times 6, if you haven't picked up on that yet, it is 4. 2/3 of 6 is 4. And last but not least, add 1 to both sides. Y will equal 2/3 x plus 5. So this is the equation for number 5. a point that, or a line that is parallel to line T and passes through point E. Now the last one, I don't even believe I need to scroll down to it. I imagine it's the equation of line through point E that is perpendicular to line T. So we're going to approach it the same way we did item 4. So if the slope of line T is 2/3, then we're going to use a perpendicular slope for our new line. Again, if our original slope was positive 2/3, our perpendicular slope will be a -3/2. And we're going to go with point slope again. So I'll go and relabel this if you need me to. -6 is x1, 1 is y1. So y minus y1, which is going to be 1, equal to, and now the only difference here is we're going to use our new slope. It's going to be a -3/2 times x minus x1, which is -6. Just like on the last one, I'm going to change, when we subtract a negative, I'm going to change that to addition. So that's going to be the only change here. And now I'm going to go and perform distributive properties so I can simplify this right side. So I'm going to distribute this -3/2. -3/2 times x is -3/2 x. And -3/2 times 6, in case you forgot this one, we'll go and do that math real quick. Again, I'll put 6/1. -3 times 6 is -18. 2 times 1 is 2. And -18 divided by 2 is -9. So we'll drop in -9 there. Last and certainly not least, we're going to add 1 to both sides to cancel out this -1 on the left-hand side because our goal is to set it equal to y. -1 plus 1 is 0, so we're left with y equals -3/2 x minus 8, because a -9 plus 1 is a -8. And that is the equation for the line through point E that is perpendicular to line T. So just a nice review for us, hopefully, of the equations of parallel and perpendicular lines. That is the end of skill lesson 16. Hope that helped. Thank y'all for watching.